we talked about the dependent, independent variables and control groups. Right now, you should try out this bell work, okay? So if you're watching this video, the bell work's below the video. If you're here in class, I just handed it to you. I want you to knock out this bell work for me. This will be great practice. If you feel confident about this after you leave today, you're like, all right, that part of the quiz, I'm going to dominate. Remember, you have the bright color answer keys on your desk, unless someone stole them, and I'll replenish them for you. So you can do a couple problems, check a couple. Do a couple, check a couple. And feel free to put a little paw up if you need some help. I will be around to help you out. What are the yellow answer keys for? That'll be something we're working on later, so you can go ahead and ignore those for now. Couple minutes on the clock, go ahead and get cooking. You guys had some time on this. You can go ahead and see the answer key below this video or in front of you. Is there any particular problem you guys would like to go over before we move on to the graphing stuff? Anyone want? You can just pick one out and be like, do number 5, do number 2. Anything you guys want? For gravy? Okie dokie. You got the answer keys below this video or right in front of you if you're in person. Let's go ahead and talk about graphing. So this will definitely be on your quiz on Thursday. You will be given a bunch of numbers, but like, make this a graph. Now, let me be really clear about something, okay? Now, we've always been taught beauty is on the inside, not the outside, right? Right? Well, I'm here to tell you that's absolutely wrong for graphs. It's wrong for graphs, okay? Your graph is useless if it's ugly. Does that make sense? Okay, your graph needs to look nice. It needs to be easy to look at and understand. That is the point of a graph. You take a bunch of numbers, you're like, what does this mean? And just give you a nice, clean visual, okay? This is a beauty contest for the graphs. Make sense? Okay, so we don't want a hot mess where Mr. Pilcher's like, which way is up? I don't even know what's happening on your graph right now, okay? We want it to be like, Mr. Pilcher looks at it, takes him like 2 seconds to know exactly what's happening, and it's really clear. Make sense? All right. So I just want to let you guys know, Mommy, my teacher said beauty is on the outside. Oh, for graphs. For graphs. All right. So let's go ahead and talk here. A little bit of reminder. So independent variables. On these little charts right here, they're always on the left side, and the dependent is always on the right. Okay. The independent variable is what you are testing, by the way. Remember that? That's the one you were testing, is independent variable, the one you were testing. And the dependent is the one that you are measuring. The one you're measuring. Another way to say that is, okay, the independent variable, I chose to make a change with that before the experiment ever started because I want to test it. I want to see what it does. The dependent variable, that's when we're like, I have no idea what the numbers are, and so we actually do the experiment because I need to observe those during the experiment. I need to measure those. So that means our independent variable will be our time here on this one. So it'll be on our x-axis. And distance, we have a couple distances here that'll be on our y, because those are dependent. The distance those rockets travel depends on how much time has gone by. Okay? So I need to make these graphs. Now on your quiz on Friday, you will have this standard grade, or this rubric right here for your graph. Okay? So what I'm going to suggest you do is I would just go through each section of the rubric, add that onto your graph, and then cross it off when you know that you've done it. That way, you won't forget anything. Does that make sense? So the very first thing says, give me a descriptive title at the top. All right, sweet. This does not have to be winning a poetry slam contest, okay? I would include something about your independent variable and your dependent variable. You do not have to have this exactly, but I wrote something like, I don't know, rockets distance traveled per second. You could have said over time, or meters traveled over seconds, or something like that. Like, just make sure it's clear that we have a general idea what this graph is going to be about. Okay, this does not need to be something like, wow, what beautiful words they have on top of it. Like, no, just make them simple, clean, easy to work with. So I got a title now. Fantastic. I'm going to go ahead. I'm going to go back to my rubric. I'm going to be like, yep. Done. Boom. I'm just going to cross it off. You're like, I did it. Check mark, smiley face, whatever it is you want to keep track of. There you go. Next, I need to put labels on each axis. Okay? Labels on each axis. Well, my independent variable is time in seconds. My dependent is distance in meters. So here's me. I'm going to go ahead and slap some time. Where should I put time again? It should be on which? x-axis because it is the independent variable. So I'm going to put time right here. Now, what flavor of time am I talking about? Am I talking about hours, days, months, seconds? So I need to say that too. Put it in parentheses afterwards. Mr. P, what if I just put a capital S in parentheses? Is that okay? Yes, that's okay. Because I'm not going to be like, capital S, does she mean hours or something? I'll be like, no, she means seconds. I know what she's talking about. Over here, I'm going to slap my distance. My distance is in what? Meters. So I got to make sure I indicate that in parentheses afterwards. Okay, sweet. I got my axes labeled. I'm going to go ahead and be like, yep. Labels on each axis. Independent, done. Dependent, done. All done with this. Great. So you're just knocking out point after point. Okay, you're getting more points every time you check one of these off. Proper units next to the labels. Oh yeah, I just did that too. Meters and seconds. Thank you. Come again. Scaling of each axis. This is the most likely place that you will be losing points on Thursday, is you want to scale it. Okay, 2/3, 3/4. Basically, you want your graph to take up most of the graph paper. Okay, you want the graph to take up most of the graph paper. So, don't overthink it. Keep it clean, keep it pretty. So time in seconds goes from 0 to 36 seconds. So my graph, my x-axis has to be a little bit wider than that. Okay. Now, what is a nice clean number that's bigger than 36? What's the next like clean number after that?
47.
I'll go 47.
I said 37.
37. Oh, I see what you're saying. I wouldn't choose 37, and the only reason why is because 37 is kind of hard to divide. Okay, because you're like, well, what are the multiples of that? Are there even any? I think it's a prime number, potentially. Doesn't matter. But it'll make it hard to make lines for that. But 40, you can divide that by 2, 4, 5, 8, 10. Like, there's a lot of ways to divide that. You're looking for those. So I'll go with 40 here. Okay? And with my rockets, one goes up to 98, one goes up to 89. So what's a nice clean number that's more than 98? 100. Let's go with 100. Boom. So I'm going to make my rockets range from 0 to 100. So now I'm over here. I need to count how many squares I got in my x. So I have to get to 40 down here, okay? And this is my 0 seconds. You got to get to 40. So halfway there, it should be 20, right? So, bless you. If I'm counting my squares, if you count across, you'll find that there are 20 squares, okay? So my 10th square should be 20. That's halfway. And then halfway between 0 and 20 should be 10. And see how this is much easier? So if you're trying to divide like 37 by a half and then you had to divide that by a half, that'd be a little bumpy. Does that make sense? So you want to make your life easy. Now my y-axis is thankfully also 20. So if I'm at 0 at the bottom here, 100. So halfway would be 50. And then I can kind of see like, oh, okay, each one's got to be 10. So every 2 is going to be 10. Something like that. So you can see why it's a nice advantage to go up to 100 because it's clean, it's easy to divide by. Life is good.
Wait, is it 10 on this distance side as well?
What's that?
So is it 10 on the distance side as well?
I went up by 10s. You could have gone up by 20s if you want to. You just have to make sure, like, if this is 0 and that's 100, each one of these lines is going to be 5. Okay? Each one of those lines is going to be 5. So I labeled all my 10s. If you're Riley, you're like, no, thank you. You could just label all the 20s if you really wanted to. Okay? As long as it's clear, we're fine. We're fine. Alrighty, so we got nice scales. I've now guaranteed that my graph is going to take up most of this graph paper because my scales are nicely fit to my data. Alright, so this will be all good here. I would like to point out one thing. This is going to be important for later. Your scales do not have to start at 0. Please note this. Please note that. They do not have to start at 0. I'm telling you that now because that's a very common mistake. And you'll have another graph to practice with here in a moment. You want to make sure every data point is visible. A key if needed. So we'll get to the data points here in a second. A key if needed. Okay. This particular case, it says if we have more than one set of data, we have 2 rockets, okay? So here's what you should do. You should just pick 2 colors. Pick 2 colors that are not super similar, so don't go with blue and navy blue. Give me like a black and an orange, or a red and a green, or a blue and a yellow. Just 2 things that stand out from one another. A lot of people like to use their regular pencil, so that's like a gray, and then just pick 1 color. Whatever you want, I don't care. On my particular graph, I just went with red and green. You can do whatever you want, as long as they're kind of different. It's easy to see the difference. Here's how I put a scale, by the way. I did this. I was like, the rocket number 1 equals red. I just put a red blob. That way, if Emerson's reading my graph, she's like, okay, the red stuff is rocket 1. She has no doubt in her mind. Okay, it's very simple. And I just put, yeah, rocket 2, green blob. There you go. Anything in green is for rocket 2. And then I went ahead and filled in my data points. So take a look at how I did my graph here. So you can see I have clear data points. See, data point, data point, data point, data point, data point, data point. But then when I did the end is I sort of tried to smooth them out with a line. Now, I didn't go intersect every single data point perfectly. Like, look at this red one right here. It's not perfectly on that line. But you just want to smooth it out so the line is kind of right next to or going right through your data points. And that's looking pretty nice right there. That's looking pretty nice right there. That's a pretty good graph. The last question we have is, what type of relationship is this? I will ask you this on the quiz. So, time and distance. Here are the types of relationships. If they do the same thing at the same interval, they're direct. So if your 2 variables go up together, direct. If they go down together, direct. They're directly connected. If one goes up while the other one goes down, that's indirect, and vice versa. The other one goes down while one goes up. So in this relationship, as time goes up, what does the distance do? It goes up. So this would be what kind of relationship? Direct. Okay. And so you'll have a place to indicate that on your quiz where you'll probably just circle direct or indirect, that kind of thing. Alrighty, so now we have another graphing table right here. We have time and minutes and mass and grams. I want you to use that second section to make another graph right here. Please pay careful attention to your ranges on this one. I'll give you a good chunk of time here to make nice, pretty graphs for me, and then we'll go over them in a little bit. So if you're at home right now, I would pause the video and go ahead and make that second graph. Let's get her cooking. Let's talk about how to do this second graph. Some of you guys aren't quite done, and that is okay, but there are some key talking points I want to go through on this one. So let's talk about this graph. It's time and mass. You're like, well, like, what is this even about? Like, are we talking about what's losing mass? We don't know. This data chart is purposely giving us not that much. Okay, so I want to make sure you guys can work with it. Hey, which one of these is your independent variable? Yeah, it should be time, yep. It says the independent variable is on the left side. We kind of saw that in the instructions. But generally speaking, time is usually, if it's one of the 2 variables, time's one of the 2, it's usually your independent variable, okay? So that's going to be on your x. Your mass is going to be on your y. So let's go ahead. Let's think about the scales we want to use here. So time goes from 0 up to 90. So what's a good scale for that, you think? 0 to what? What's a number bigger than 90 that is pretty clean and easy to work with? I'll go with 100. 100 sounds good enough. The only reason I won't go with 105, because I know that they are going up with 15s. I usually have some folks who say 105. Is because 105 is a lot harder to divide when you're dividing it up into different sections. Does that kind of make sense? Now here, my top mass is 19.4. So what's a number that's clean, that's a little bit bigger than 19.4, yeah? Right, yeah. If you went with 19.5, that would not be wrong. That'd be okay. Personally, I'll take 20, because it's easier for me to divide 20 than it is 19.5. Does that kind of make sense? So I'm going with 20. If you threw 19.5 at me, as long as your scaling was accurate, we're good. Okay? Now, it goes down to 16.8, so what should I make the bottom of my range be? 15 is pretty good. 16 is pretty good. Either one of those I think would be fine. Personally, I'll go with 16. I like dividing 16. I think it's a little bit easier than dividing 15, in my opinion. But if you put 15 on there, like if you went from 15 to 19.5 or whatever, it's all right. There's a few correct ways to do it. Now, let's take a look at how this graph should sort of come out. First thing we should always put on a graph is, let's get a title. I put mass loss per minute. I don't know. Some people put decreasing mass over time. That's fine, like whatever you want. I'm going to put my units on here. So my x-axis, what's my independent variable again? And what's the flavor of that?
Yeah.
There you go. Time in minutes. Yeah. And what's over here on the y-axis? This miles or something?
No, meters.
It's kilograms.
There we go.
Meters.
Oh,
Just double checking.
Always in meters.
No, it just depends on what data you're given. Yep. So time in minutes, mass in grams.
Sometimes.
So I decided to have my time go all the way up to 100. So this is 100 over here. And this is 0 over here. So this graph is 20 wide again. So I could find the 10th one and make that 50 if I wanted to. So it'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can make this 10. If you do your, I can make this 50, sorry. If you do your math correctly, you'd realize that each one of these little lines has to be a 5. So if you want to do what the data did and count by 15s, you could do that too. Personally, that's what I did. Boom, 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 boom. But if you went by 10s on here, so you had like 10, 20, 30, 40, that would be fine too. Okay? There's a few ways to do it. I'm just going to make it easier because the data points are every 15 seconds, so I'm just going to roll with that. Make my life easier. Okay. Now some people are like, wait, but if this is 0 here, doesn't there have to be 0 there? Remember, we're talking about two totally different units. Okay? So sometimes to remind myself, I might draw like a little divider like this at an angle, like this one's 0, but then this one's going to start at something else. Does that kind of make sense? So I want to start this guy at 16, so I will. I want to end at 20, so I'll have it end at 20. So halfway in between those should be what? 18, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's halfway. So that should be 18. And halfway in between those, 1, 2, 3, 4, 5. That should be 17. And 1, 2, 3, 4, 5. That should be 19. There's a lot of little tricks. But you can see why I kind of like 16 through 20. Made my life easy. Alrighty. Now let's go ahead and plot my points on here. I'm going to check off my rubric. Okay. Oh, why is this freaking out? Looks like a rave. All right. The descriptive title at the top is good. So again, I got that. I got my labels. Yep. Proper units next to each label. You got it. Scaling. Gravy. Does not have to start at 0. Don't I know it? Yeah. I started at 16 for this particular one. Alright, so let's see here. I'm going to grab one of these worksheets so I can read off the data points myself. Yoink. We go ahead and get this. I'm going to come over here, plop, boom, boom. Let me get my data points real quick. So looks like I got 19.4 at the 0, so that would be right here. And then I got 19.2 at the 15, that would be right here. 18.9, all right. Boom. I'm going to make them nice and juicy. Like there's a big fat point right there. That way Mr. P is never wondering where my data point is. He's like, oh, I can see exactly where it is. Juicy data point, 17.9. Add a little juice on there. Boom. 17.5er. Yep. So that'd be right here. Wait. Come on, Mr. P. Get it together. Maybe slightly above that. That'd be right there, it looks like. And 16.8. Okay. So that would be, yep, right there. So, if I were to smooth this out, I'd draw something like this. Doesn't have to be a perfectly straight line. But I'm making it really easy. Mr. P can see that this graph is generally going down. Okay? Now, if you accidentally used the wrong scale, so you had like, you started at 0 and you went up to 20, your graph would be kind of looking like this at the top right there. But you see how that only takes up that much of the graph? That's why that would lose you some points because it's almost like a straight line. It doesn't tell me as much as this one that is clearly going down. Hey, what kind of relationship is this? As time goes up, mass goes down. What kind of relationship is that? Indirect. And you will have a spot on your quiz to indicate whether it's indirect or direct. I'll ask you. So you don't have to write that on your graphs, but there you go. Something like that. So we're going to talk about one more thing here. We're going to talk about how do we interpret graphs. So what if the graph is made for me? And I'm just asking questions about it. Can I do that as well? So this is the third part of what will be on your quiz on Thursday. The answer key to this next worksheet, which looks like this for you folks at home, is below the video. And if you're here in person, it's that yellow sheet on your desk. So let's just take a look at one of these, and then I'll let you guys work for the rest of the period on your own. So you know to interpret lots of different kinds of graphs, okay? Not just make them. So let's take a look at this first one. Identify the graph that matches each of the following scenarios. Okay. So this person left home, so they were going away from home. Then I realized I forgot my books, so they went back to home, and they probably went to school after that. Well, so we're told distance from home versus time. This person was just getting farther from home the whole time. So that's not that scenario. Distance from home. This person went away from home, and then they stopped moving, but they were still far away from home. And then they got further away from home. This person went away from home, but then they went back to home. And then they went away from home again. So it looks like this should be number 3. And that's how I interpret my graphs, okay? You got a pie graph and all that good stuff. Are there any questions for me? Okie dokie, like I said, the answer key is that yellow sheet on your desk if you're in person. And it's below this video if you're at home. Please let me know if you got any questions. Let's get her cooking.